will go ahead with alkaloids. So let's see what are alkaloids. Alkaloids are organic compounds basic in nature, containing one or more nitrogen in heterocyclic ring, and they possess specific physiological actions when used in small concentration. So the name alkaloid, so it is like alkali, so it is basic in nature. So why it is basic in nature? Due to the presence of nitrogen, where the nitrogen is present in the heterocyclic ring. So the heterocyclic ring can be anything, pyridine, so quinoline, anything. So these are the organic compounds basic in nature, consisting of one or more nitrogen. That nitrogen is heterocyclic in nature and possesses specific physiological action when used in small concentration. So this is the definition of alkaloid. So now let's briefly quickly see about its properties. So coming to the physical properties, all the alkaloids are colorless crystalline compounds with few exceptions like nicotine, which is volatile in nature. And next, coming to the chemical properties, so the name itself, they are basic in nature due to the presence of lone pair of electrons on the nitrogen, and the basicity increases, basic nature increases if the adjacent group is electron releasing, and the basicity decreases it is electron if the adjacent group is electron withdrawing. So this is in brief about the definition, properties of alkaloids. Now quickly let's go ahead with the classification of alkaloids. So there are various modes of classification of alkaloids. So alkaloids are classified as classified based on their pharmacological nature, based on the nature of the heterocyclic ring, and also the general classification, that is true alkaloid, proto-alkaloid, amino-alkaloid. So let's, among all the classifications, this pharmacological classification is very important. So let's quickly see what are the drugs that comes under antihypertensive drugs. So they are classified as antihypertensives. So alkaloids that comes under antihypertensive drugs are the 𝗪, that which contains reserpine. So 𝗪 is an antihypertensive drug belonging to the family of opposinaceae. So it contains reserpine. Next, bronchodilators. Under the bronchodilators comes the two drugs, that is the ephedra, which is ephedra giardiana, and which contains ephedrine, and also the drug Vasaca, so which contains vasacinone, and it belongs to Acanthaceae family. Next, under smooth muscle relaxants comes the tropane alkaloids, that is the belladonna, which contains atropine, and as well as the opium, which is the latex obtained from Papaver somniferum belonging to Papaverinaceae family, which contain papaverine. So this is the classification, pharmacological classification of alkaloids. So next, these alkaloids are again classified, the basic classification is the alkaloids are classified as true alkaloids, we have amino alkaloids and also pseudo alkaloids. Okay, so alkaloids are classified as the basic classification is the true alkaloid, amino alkaloid and pseudo alkaloids. So all the amino acids have the precursor as they have the precursor as amino acids. So as we all know, alkaloids are the secondary metabolites. So alkaloids are the secondary metabolites. So usually they are usually obtained from the primary metabolites, that is the amino acids. So all the true alkaloids have the precursor as amino acids, and one more thing is that all the alkaloids should possess a heterocyclic ring. Yes. So this is the main Heegner's classification, that is a true alkaloid. So true alkaloid, that which contain precursor as amino acid, and the type of nitrogen is heterocyclic in nature. Then comes the proto-alkaloid. So here in the proto-alkaloid, the example is usually the colchicum autumnale. So usually here the precursor is the amino acid, but it is not heterocyclic in nature. So it is present outside the heterocyclic ring. So next comes the pseudo-alkaloid. So the example for pseudo-alkaloid is the purine alkaloid, that is the caffeine. So it is heterocyclic in nature, but the precursor is non-amino acid. So the precursor, it is not obtained from amino acid. So based on the Heegner's classification, alkaloids are classified as true alkaloids, that is the precursor is amino acid and the nature of the nitrogen is heterocyclic in nature, and the proto-alkaloid wherein which the precursor is the amino acid, but the nature of the nitrogen is not heterocyclic. And pseudo-alkaloid, the example is the purine alkaloid, the caffeine. So here the precursor is non-amino acid and it possesses heterocyclic nitrogen. So another mode of classification is based on the nature of the heterocyclic ring. So the heterocyclic ring can be of many types. Like you have pyrrole ring, the examples are hygrine and coca. So pyrrolidine, it is the tropane alkaloid, that is nicotine. So pyrrolidine, it is the tobacco, Nicotiana tabacum, and you have pyridine, that is lobeline, and piperidine, it is black pepper, and imidazole, it is pilocarpine from Pilocarpus. Quinoline, it is cinchona, which contains quinine, quinidine. Isoquinolone, it is morphine, which is obtained from Papaver somniferum. Indole alkaloids, that is Ravulfia serpentina, and also you have vinca. And comes the purine alkaloids, the caffeine, which is obtained from Camellia sinensis or Thea sinensis, and also theophylline theobromine. And comes the tropane alkaloids, all the Solanaceae family members like atropine, and quinazoline, it is vasicine from Vasaca, norlupilin, it is lupilin from lupin, and also you have phenylethylamine from ephedra, that is which contain ephedrine, steroidal alkaloids like conicin, and tropolone alkaloids like colchicine from colchicum autumnale. So this is all about the brief classification. Next comes the chemical test. So all the alkaloids should obey the 4 chemical tests. So these are Mayer's test, First one is the Mayer's test, second one is the Dragon-Roth's test, third one is the Wagner's test, and fourth one is the Hager's test. So these are the precipitation tests for alkaloids. So these are also known as precipitation tests which all the alkaloids should follow. So the name Mayer's test. So Mayer's test contains Mayer's reagent. So the composition of Mayer's reagent is PMI. So here we have got M. So you have M here, that is potassium mercuric iodide. And the color of the PPT is cream color. So as you have got M here, you can remember M mercury and M is for cream. So Mayer's reagent which possesses potassium mercuric iodide which gives cream color precipitate. Next comes Dragon-Roth's. So here you can remember D, and in place of D you can remember as B. So it is PBI. So what is PBI? It is potassium bismuth iodide. So usually here we will get B is for brown again, that is reddish brown precipitate. So reddish brown precipitate. So Dragon-Roth's reagent, here you need to remember B. B is for bismuth and also brown or brick red precipitate. So next comes the Wagner's. And first let us quickly see about Hager's. So it is nothing but picric acid. Okay. So picric acid is, as we all know, it is yellow in color. Hence we get yellow precipitate when we add to an alkaloid. Then comes the Wagner's. So here you can remember it as IPI. So IPI is nothing but iodine in potassium iodide. So iodine in potassium iodide, this also gives reddish brown precipitate. So questions may be asked from this chemical test, general chemical test for alkaloids. So here you need to remember about the reagents. So easily you can remember if you know about the shortcuts. So here you can remember as M, that is potassium mercuric iodide. Here in place of D you can remember as B, that is potassium bismuth iodide. And here you can remember the word IPI, that is iodine in potassium iodide. And in the Hager's you can remember it is picric acid solution. So picric acid is yellow in color, you will get yellow color PPT. These are the general chemical tests, general precipitation tests for all alkaloids. So apart from the general chemical tests, we have specific tests for specific alkaloids, specific group of alkaloids. So we will go ahead with the specific tests as well, which are very, very important. The specific chemical test for all the tropane alkaloids. So most of the tropane alkaloids, it is 𝗪𝗎-Morin test. 𝗪𝗎-Morin test is the specific chemical test for tropane alkaloids. All the tropane alkaloids which usually belong to the family of Solanaceae. That is, it is Datura, it is Belladonna, Hyoscyamus. So all the tropane alkaloids which possess a tropane ring, they obey 𝗪𝗎-Morin test or 𝗪𝗎-Morin reaction. So What is the procedure? So, here we need to take the drug. To that we have to add HNO3, that is fuming nitric acid, and subjecting it to evaporation to dryness. So, after we have to take the extract of the drug followed by addition of fuming nitric acid and subject that to evaporation. So, and the residue which is obtained is treated with acetone and methanolic KOH. So, methanolic KOH. So, the residue when upon treated with acetone and methanolic KOH, it gives violet or purple color. Okay. So, you can remember V is for violet. So, hence you will get violet color, and you can remember here N. So, N is HNO3. So, fuming nitric acid. So, here the drug is treated with this HNO3 and subjected to evaporation, and upon addition of A is for acetone. So, and KOH, you will get violet color. So, this is all about the tropane alkaloids, that is the test for tropane alkaloids Vitali-Morin reaction. So, Vitali-Morin reaction, initially we have to take the drug and we have to treat it with here HNO3, fuming nitric acid, followed by evaporation to dryness, followed by treatment with acetone, followed by O, KOH, methanolic KOH, methanolic KOH, M, you will get V, violet color. So, this is positive for all the tropane alkaloids, that is belladonna, datura, hyoscyamus. Next comes the test for indole alkaloids. So, indole alkaloids include ergot, which contain ergotamine, which is oxytocic, and apart from that you have got vinca. So, in all the indole alkaloids show positive test for Van Oert's reaction. So, Van Oert's reaction, it is simply para-dimethyl amino-benzaldehyde and also followed by sulfuric acid. You will get blue color. So, sample reacts with para-diamino-benzaldehyde and diluted sulfuric acid gives blue color. So, this is Van Oert's reaction or Van Oert's test, which is positive for all the indole alkaloids. Next comes the test for quinoline alkaloids, that is cinchona alkaloids. So, the name itself, that is thaloquine. So, here quin and here quin. So, quinoline alkaloids show thaloquine test. So, here in the thaloquine test, you just have to remember bromine water and strong ammonia. So, when the drug has been treated with bromine water in presence of strong ammonia, you will get emerald green color. Okay. So, this test is for quinoline compounds or quinine alkaloids, that is cinchona alkaloids, which contains quinine, quinidine, okay, which is an anti-malarial drug, which shows the test called thaloquine test. Thaloquine test gives emerald green color. So, question may be asked, what is the color of the reaction for thaloquine test? That is emerald green. And they may ask, thaloquine test is for which type of alkaloids? That is quinine alkaloids or the anti-malarial drug which shows which is positive for thaloquine test, that is cinchona. So, questions may be asked the opposite way. So, and also what are the ingredients of this thaloquine test? Bromine water and strong ammonia. And the last test, which is positive for all the purine alkaloids, caffeine. So, it is Murexide test. So, question may be asked like which of the pseudo alkaloids shows positive reaction for Murexide test. Then you have to answer it as caffeine. So, pseudo alkaloid is caffeine because it is, the precursor is non-amino acid in nature. So, this caffeine shows positive reaction for Murexide test. So, here the caffeine after extraction has to be treated with potassium chloride and dilute HCl. So, followed by exposing to strong ammonia vapors. So, here caffeine after the extraction is treated with potassium chlorate and followed by dilute hydrochloric acid. So, and we have to subject it to evaporation and to finally we have to expose that to strong ammonia vapors. So, the color here is violet color. So, the question may be asked, for which of the tests the end point is violet color. So, here it is positive for murexide as well as 𝗪𝗏 test. 𝗪𝗏 test also shows violet color and also murexide test shows violet color. So, these are the specific chemical tests for specific alkaloids. So, tropane alkaloids, it is 𝗪𝗏 reaction or 𝗪𝗏 test. So, for indole alkaloids, it is Van Eurk's test. For quinoline alkaloids, the name itself Thalloquin test. So, purine alkaloid is pseudo alkaloid. So, the chemical test is murexide test. So, these are the specific chemical tests for alkaloids. Then we will go ahead with a few specific drugs of alkaloids. So here we have got 14 drugs to learn. So, among them the first one is the areca nut. So, it is also known as chewing nut. So, this areca nut is also known as chewing nut. So, areca nut is a chewing nut which you will be using for spiritual purpose. And it is obtained from a palm tree. So, tall palm tree which possesses a fruit. Inside the fruit we have only a single seed called a nut, that is areca nut. So, here the morphological characteristic is the presence of a yellow color protective layer called testa. So, it is obtained from a palm tree. So, areca nut are the dried seeds. So, what is a part? So, nut is the seed which is present in the fruit. So, fruit that bears a seed. So, that is nothing but the areca nut. So, areca nut is the dried seeds of a palm tree, tall palm tree. The name, scientific name of areca nut is Areca catechu. Areca catechu. So, as it belongs to palm tree, the family is Palmaceae. So, Areca catechu belonging to the family Palmaceae. So, coming to the morphological characters, so it is a tall palm tree which bears a fruit. The fruit is having a single seed. So, that seed is this areca nut and it is having a seed coat. The seed is having a seed coat. So, when we do the transfer section and observe, so usually it has a seed coat and followed by a yellow colored layer called yellow, or it can be deep brown layer called testa, which is protective in nature, and the innermost part is the endosperm, which is nutritive in nature. Okay. So, these are the morphological characters. So, usually it is a tall tree. So, tall tree which possesses a fruit. The fruit bears a single seed called areca nut. So, superficially it is usually brown in color and it possesses a yellow colored testa and an endosperm. So, coming to the category, so usually it contains pyridine, piperidine type of alkaloids. So, pyridine, piperidine type of alkaloids. As we all know, this is the structure of pyridine. So, it has pyridine and piperidine structure of alkaloids. The main alkaloids are arecholine and arikadine. So, arecholine and arikadine are the main alkaloids which are present in areca nut, which is also known as chewing nut. So, usually coming to the uses, it is parasympathomimetic and parasympathomimetic that mimic the actions of acetylcholine. So, parasympathomimetic that mimics ACH. Apart from that, it is antihelminthic that works against the worms, aphrodisiac, that is it increases the sexual desire, nervine stimulant, immunogogue, that is increases the menstrual flow. So areca nut, these are the uses. So it mimics the action of ACH, that is parasympathomimetic. It is antihelminthic, aphrodisiac, nervine stimulant and immunogogue. And coming to the adulterants, which are very, very important. So adulterants are areca caliso, so 𝗟𝗏 cornicina, 𝗟𝗏 𝗍𝗏𝗏, 𝗟𝗏 laxa, 𝗟𝗏 nagens, 𝗟𝗏 triandra and 𝗪𝗏𝗏𝗃𝗃𝗃 heterospathe-illata. So these are the adulterants. So question may be asked, which of the following is not the adulterant, or which of the following is adulterant of the areca nut, that is 𝗟𝗏 catechu. So the main species is, the genus is areca and the species is catechu. Apart from that, it is substituted, areca catechu is substituted by following species, that is caliso, cornicina, 𝗍𝗏𝗏, laxa, nagensis, triandra. So these possess the same genus as areca, but the species are different. As we all know, so adulteration is practice of substituting the original crude drug with the other inferior drugs which may possess or may not possess the chemical constants and activity as that of the original crude drug. So areca catechu, apart from the areca genus, it has got other two drugs, that is 𝗪𝗏𝗏𝗃𝗃𝗃 heterospathe-illata. So these are the adulterants of areca nut, which is also known as betel nut, which is a chewing nut. So areca nut, areca catechu, belonging to Palmaceae family, as it comes from a tall palm tree. So superficially it is brown in color and usually thin seed coat, it is single seed, and usually it has a testa, which is protective layer, yellow color or brown color, and an endosperm. It has got pyridine, piperidine type of alkaloids. The name itself, areca means choline is the chemical constants, and also aricadin, and uses, it is parasympathomimetic and antihelminthic and aphrodisiac, nervine stimulant, immunogogue. So this is all about the pyridine, piperidine alkaloid, that is areca nut. Next we will go ahead with the tropane alkaloids. So the first drug under tropane alkaloids is belladonna. So usually the name belladonna, you can just remember belladonna has fruits similar to that of brinjal. So just like you can see here the picture of belladonna. So usually these are all Solanaceae family members having purple color or violet color and green color fruits. So usually the source is either the leaves, flowers, but here officially we will go ahead with the leaves. So these are the dried leaves of Atropa belladonna. So Atropa belladonna belonging to the family Solanaceae. So most of all the tropane alkaloid members belongs to the family of Solanaceae, and tropane alkaloids obey Vitali-Morin reaction or test. So this is very important. And coming to the morphology, as we all know, the leaves are green to brownish green in color. The flowers here you can see they are purple in color, purple to yellowish brown in color. So usually the leaves are either oval or lanceolate with entire margin. So margin is the smooth margin. So either the leaves are ovate in shape or they are lanceolate. So they are usually elongated. Lanceolate means elongated. So these are the morphological features. So question may be asked, so what is the shape of the leaf? So it can be ovate or lanceolate. And the margin, so margin of the leaf is entire margin, that is smooth margin. So the smooth margin. So tropane alkaloids, so the main alkaloids are hyoscyamin and its racemic form atropine. Hyoscyamin and atropine are the chemical constants of belladonna. So usually it is used as parasympatholytic agent with anticholinergic property. So here we have seen 𝗪𝗪choline, which is parasympathomimetic, that is it mimics the action of ACH, whereas the tropane alkaloids, all the tropane alkaloids have parasympathomimetic activity, that is they show anticholinergic properties. So it reduces the secretions like sweat. Apart from that, it is used to treat, it is used as an antidote in opium and chloral hydrate poisoning, opium poisoning and chloral hydrate poisoning. So these are the uses of belladonna, which possess hyoscyamin and atropine, its racemic form atropine, which is a tropane alkaloid. So usually belladonna is adulterated with the leaves of Phytolacca americana and also Solanum nigrum and also Elianthus glandulosa. So it is adulterated with Phytolacca americana, Solanum nigrum as well as Elianthus glandulosa. So these are the adulterants of belladonna. So belladonna, it is Atropa belladonna Solanaceae family. So it has got main hyoscyamin and atropine. So it is parasympatholytic drug which possesses anticholinergic properties. It reduces the sweat. Apart from that, it is used against opium and chloral hydrate poisoning. So the three drugs which the belladonna is adulterated with three drugs, that is Phytolacca americana, Solanum nigrum and also Elianthus glandulosa. So superficially they may look similar, but the constants will differ, the presence of the alkaloids and the activity of parasympatholytic, it will differ. Okay. So next we will go ahead with the tropane alkaloids. Yes, the other tropane alkaloid is hyoscyamus. So the second tropane alkaloid, hyoscyamus, the name itself, it is obtained from Hyoscyamus niger and it belongs to Solanaceae family. So it is, the source is either the leaves or flowering tops. So in all the tropane alkaloids, the biological source is either the leaf or the flowering tops. So it is the leaves or flowering tops of Hyoscyamus niger belonging to the family Solanaceae. So here the leaf is oblong or egg shaped, that is oval, or it is elongated, oblong, long, and usually the color is same, greenish in color, covered with sticky hairs, that is the trichomes. And coming to the main alkaloids, the name itself, hyoscyamus, possesses hyoscyamin in the major amount, that is 75%. Apart from that, it has got other tropane alkaloids like hyoscine and atropine. So this is the structure of hyoscyamin which possesses a tropane moiety. So this is hyoscyamus. Next, hyoscyamin. Next, coming to the uses. So it is used, apart from the parasympatholytic, it is used to counteract the gripping effect due to the purgatives. That is, as we all know, the senna and all, which are laxative or purgative in action, when used in more quantities, they possess gripping effect, that is pain in the abdomen. So in order to counteract that, we will use hyoscyamus. Apart from that, it is used as expectorant, antispasms to reduce the spasms, and also anti-asthmatic. Okay. So these are the uses, and it is adulterated or it is substituted with only one species, that is Egyptian henbane. It is commonly known as henbane, that is muticus, Hyoscyamus muticus. Hyoscyamus muticus is the only adulterant of Hyoscyamus niger. So actual species is niger, it is adulterated with muticus. So this is all about the Hyoscyamus. So Hyoscyamus is Hyoscyamus niger. So it is the part used is the leaves or the flowering tops. So the name itself hyoscyamus, so it possesses a chemical constituent hyoscine in major amount. Apart from that, it possesses atropine and hyoscine, and it is used to counteract the gripping effect caused by the laxatives, and also expectorants, reduces the spasms, and also anti-asthmatics used in asthma, bronchial asthma. So it is substituted with only one drug, that is muticans. So another, let's go ahead with another tropane alkaloid, that is stramonium. So this stramonium is commonly known as datura. So datura, it is the leaves and flowering tops of datura stramonium. Here you can see the difference, almost they look alike, but morphologically they look alike, but the species and the constants differ. This stramonium is datura stramonium. All of them belong to same family, Solanaceae family. So the belladonna, hyoscyamus, stramonium all belongs to Solanaceae family, and they give positive reactions for Vitali-Morin test. So usually the leaves are all greyish green in color. So the taste is bitter, the shape is ovate with short petiole. So stalk is very short and unequal base. So unequal base means this both does not touch at the same point, so unequal base. So usually it possesses all the alkaloids like hyoscyamin, hyoscine, and small quantities of atropine. So the major constants are hyoscyamin and hyoscine, which is also known as scopolamine. So hyoscine is also known as scopolamine. So hyoscyamin and scopolamine in major quantities, and small quantities of atropine, whereas in hyoscyamus, hyoscyamin in the major amount and less amount of atropine and hyoscine or scopolamine. And usually it is used in the treatment of asthma. So it is substituted by xanthum, stramonium, which belongs to Compositae family, and Solanum nigrum. So actual species is datura stramonium. So it is substituted by Solanum nigrum, which also belongs to Solanaceae family. So there are two adulterants, xanthum stramonium and Solanum nigrum. So this is all about the stramonium. And we have got one more tropane alkaloid. Duboisia. So the last tropane alkaloid is Duboisia. So this Duboisia it is a tropane alkaloid So, it is obtained from Duboisia myoporrhites. It is having two species, and also 𝐿𝐻_Hardy. So, it is obtained from two species, that is myoporrhites and 𝐿𝐻_Hardy, and it also belongs to Solanaceae family. So, the leaves of myoporrhites and 𝐿𝐻_Hardy. So, usually leaves are tapering at both the ends and usually green, and they are intensely bitter. So, all the Solanaceae family members are bitter in taste, and the parts used are the leaves and flowering tops. And the main constituents are, it is a chief source of scopolamine. So, scopolamine is also known as hyoscine and also atropine, the tropane alkaloids. And coming to the use, atropine, as we all know, parasympatholytic drug, and it also stimulates the central medullary and nerve centers, and also it is an antidote for pilocarpine. So, pilocarpine as well as physostigmine and also choline esters. So, and also it relieves the bronchial spasms, and it also used in the peptic ulcer. It suppresses the gastric secretions. So, it possesses parasympatholytic activity, that is, it is having opposite actions of ACH, that is and pilocarpine, which possesses parasympathomyopathic activity. So, it is used as an antidote in case of poisoning caused by pilocarpine and physostigmine, which have the action similar to ACH. and also bronchial spasms or bronchial asthma. It relieves the bronchial muscles and also gastric secretions, hence it is beneficial in peptic ulcer treatment. So, this is the last drug 𝗪𝗵𝗂, which is a tropin alkaloid. So, it is a chief main source of the tropin alkaloid, scopolamine and atropine. So, next comes the coca. So, usually coca is nutritive in nature, and the coca is where the chocolates are prepared from. We will be using coca for the preparation of chocolates. So, it is obtained from the seeds of 𝗪𝗵𝗶𝗁 coca belonging to the family Stericulaceae. So, it is the seeds of 𝗪𝗵𝗶, the name itself 𝗪𝗵𝗶 coca belonging to the family Stericulaceae. So, usually the seeds, the fruits are yellowish red having many seeds. So, the fruits bear seeds which are reddish brown in color, characteristic odor, and they possess astringent activity. So, they cause precipitation of proteins, and the shape of the seeds is ovoid to flattened in shape. So, the 𝗪𝗵𝗶 coca, so they have characteristic pleasant odor, astringent taste, and they are ovoid and flattened in nature. And the main chemical constants, the name itself 𝗪𝗵𝗁. 𝗪𝗵𝗁, it possesses theobromine. So, theobromine is the major constant. Apart from that, it has got caffeine and polyphenols. So, this is the structure of theobromine, so which is methyl xanthine, which possess purine or xanthine structure. So, which is also a pseudo alkaloid. So, this is coca, 𝗪𝗵𝗶 coca, Stericulaceae family. So, possessing 1% of theobromine and less amount of the other xanthine drugs or other purine drugs, caffeine and also polyphenols. So, the main important use is diuretic in nature. So, it is diuretic in nature, nutritive, and it is used in the preparation of cocoa butter, which is the main ingredient of suppository base. So, suppositories, it is used in the preparation of suppositories. So, this is all about the coca, so which is 𝗪𝗵𝗂 coca, so which process theobromine in the major amount, so which is used as diuretic, so which increases the volume of the urine, nutritive in the preparation of chocolates, and also cocoa butter, so which is having emollient action and the preparation of suppository bases as well as creams. Next, other pseudo alkaloids include caffeine and the coffee and tea. So, coffee is obtained from Coffee arabica, seeds of Coffee arabica, which belongs to Rubiaceae family. So, coffee beans are seeds or beans are obtained from Coffee arabica. So, they belongs to Rubiaceae family, and usually initially the seeds are green in color, fresh seeds are green in color. Upon roasting, they acquire brown color, and the odor is agreeable and the pleasant odor, and the taste is bitter in taste. And the main constant of coffee is caffeine. As we all know, the coffee contains more amount of caffeine than tea. So, apart from the caffeine, it possesses dark color tannins, fixed oils, and also proteins. So, this is structure of caffeine. And next, coming to the uses, as we all know, caffeine is used as CNS stimulant as well as diuretic. So, hence the use of coffee is stimulant as well as diuretic. So, coffee is usually adulterated or substituted with roots of chicory. So, this is very important. coffee is adulterated with chicory. So chicory is mainly a carbohydrate drug which contain inulin and it possesses blue flowers. So here the chicory roots, these are dried and powdered and they are substituted for coffee. So the scientific name is of chicory is Chicoryum intybus, which belongs to Compositae family. So the main adulterant is chicory. Coffee is substituted by chicory, roots of chicory. So the main constants of chicory are, it possesses the carbohydrate inulin. So usually it is nutritive in nature. So apart from that, it is substituted by husk, stem and also other grains like corn, barley, wheat and also woody tissue. As it is brown in color, it is substituted with woody tissue, but the main constant is chicory. So this is all about the coffee. Next comes the important purine alkaloid or the pseudo alkaloid, tea. So usually tea, so the fresh tea leaves are obtained from the buds of 𝗪𝗪 or Camellia sinensis. So the scientific name of tea is 𝗪𝗪 sinensis or Camellia sinensis, belonging to the family Theaceae. So tea belongs to family of Theaceae. So usually the fresh leaves are green in color, odor is agreeable odor and characteristic, and the taste is bitter, astringent, and the shape is lanceolate shape, and these are the morphological characters. And coming to the chemical constants, so it has got the caffeine as a major constant, 1 to 3%, tannins, theophylline, theobromine. So apart from the caffeine, it also possesses theophylline and theobromine. So as in coca, so coca contains theobromine and theophylline as well. So these are the constants of caffeine. So question may be asked, what are the other constants of caffeine? Or caffeine contains only caffeine, theophylline, theobromine, all of the above. So caffeine tea contains all the constants. So use is CNS stimulant, and the use of theophylline, theobromine is anti-asthmatic. Apart from that, caffeine also has diuretic property. So usually tea is substituted with the exhausted tea leaves. So the tea leaves, after the boiling, the decoction and preparation and all, so they are usually dried and resubstituted for the profit purpose. Usually tea is substituted with exhausted tea leaves. So this is all about the coffee and tea, which are the alkaloids. Thank you.